So what we've got is 5 flasks here, numbered 2 through 6, and you can see the flasks all have numbers on them, 2, 3, 4, 5, 6. You'll also notice there's balloons, and they also have numbers on them as well. They're numbered 2 through 6 as well. Now this one has already been weighed, and what you can see here is we have a balloon and it's attached to a powder funnel. Now what Reese is going to do is he's going to weigh that, and he's weighed it. It's, in this case I think it looks like about 25.30 grams, remembering that we weigh this to 2 decimal places. And we need for our first sample to have between 3.5 and 4.5 grams of sodium carbonate in our sample. So what he's going to do is he's going to add sodium carbonate until it reaches 28.80 grams, or between 28.80 and 29.80 on the scale. That's going to be the mass of what he's got so far, which is 25.3 plus 3.5 up to 4.5. So go ahead, Reese, and let's add the sodium carbonate to our balloon and funnel assemblage. And put about 3 or 4 scoops in to begin with. That'll do. And let's see where we're at. So remember, he wants to get it somewhere between 28.8 and 29.8, and presently he's not quite there yet, so he's going to add a bit more. Now it looks like you've added about a gram, so you can see that it looks about 3 scoops makes up a gram. So let's go ahead and add another. Well, that's a pretty big scoop. Keep going though. Keep going. Alright, let's try it now, see where we're at. So it's just trial and error until he gets up to between 28.8 and 29.8. Now he's not quite there yet, he's at about 28.6. So he's going to add maybe another 2 scoops, and then he'll probably leave it at that. So we're pretty much on the edge there, about 29.8 grams, and that's where he'll leave it, and then he'll move on and he'll do the next one the same way. I think you need between 4.5 and 5.5 grams on the next sample. So this is trial 6, and Reese has weighed the powder funnel and the balloon, and it's come out to be about 24.55 grams. Please note that they're going to all weigh a little bit different, so it's not like you can just weigh one and just assume that's going to be the mass for all of them. Now, because we need between 11.5 and 12.5 grams of sodium carbonate, we know that we want the total measurement here to be between 36 and 37 grams. That's 24.5 plus 11.5, so it's going to be close enough anyway, about 36.05 to 37.05 grams. So go ahead, Reese, and let's start adding sodium carbonate to that. A fair amounts in this time, so he's going to go ahead and pile it in initially. How many scoops do you think you'll need? Fair number, huh? He's going to he's going to put in about initially probably about 10 scoops or so, right? Then he'll check on the mass and see where he's at. Okay, let's give it a go. going to make sure it's in the notch, like we do. And this clearly isn't enough yet. You need about 36, so. So you can see that for these larger samples, obviously you're going to need a lot more scoops of sodium carbonate. Let's give that a go, Reese. We'll see where you're at. It's getting close.
It's getting there.
Yeah, so he's at about 35 grams now, so he's going to add another couple of scoops. Remember, he wants to get between 36 and 37 in here, because that total mass will produce between 11.5 and 12.5 grams of sodium carbonate. Alright, let's stop there for a second. Let's give it a go. You want to try and avoid putting too much in. Move a little bit more, and he's definitely got between 36 and 37 there, so he's going to mark whatever that is down, and then that's going to be the mass that he'll put into his result sheet. Now, into each of these flasks we need 100.0 mils of acetic acid. So what Kanan has done, he's got his 1 point. Could you show that on the screen, please? There we go. Then bring it over. 1.0 molar acetic acid. That's good, thank you. And he's put it into 100 mil graduated cylinder. So that's going to be 100.0 mils of acetic acid. Now go ahead and pour it into flask 2, please, Kanan. Now what Kanan will also do after he's done that is he will put 100.0 mils into all the flasks. Now all the balloons will be placed onto the flasks. Could you please go ahead, Reese, and show that one going on there? There you go. Make sure they're on fairly tight and that they don't slip off. There we go. So we've got all of those balloons on the flasks now. So now what we're going to do is we're going to run the experiment. There is sodium carbonate in all these balloons, and what each of these students is going to do is they're going to lift up the balloon and sodium carbonate is going to fall in the flask, and then they're going to start spinning the flasks. So go ahead and do that for all of them, please. And then give them a swirl. And when I say a swirl, just, there we go. And you can place them down on the bench and just swirl them while they're on the bench. There we go, just like that. Reese, that's perfect. Now, the thing is, I don't want you to expect that all of them will have everything dissolved. Some of them will have the sodium carbonate completely dissolved, but some of them won't. And the reason for that is because of the whole limiting reagent thing. In the earlier samples, we might expect that sodium carbonate might be the limiting reagent, and what will happen is that it will completely dissolve in maybe some of the earlier ones. But in the later ones, we would expect that it may not dissolve. So go ahead and keep swirling it. You've got to keep swirling it. So if it does dissolve, we'll be able to manage to see it happen. Now this is going to have to go on for about 5 minutes to make sure that we are indeed getting a full reaction here. Now once they stop bubbling, you'll know that the reaction is pretty much over. Now Reese is going to go ahead and measure the diameter of one of these balloons. Now they're not spherical, he's just going to go ahead and measure it at the widest point that he can here using the calipers. He's going to hand me the calipers. I'm going to show you how to read them. My favourite kind of caliper is this kind. It's the wheel caliper. with the dial on it like this. Now the way that it works is that you can see this is in millimeters here, so that's 100 millimeters, so we know it's between 100 and 110. And then we've got the dial here that will measure between 0 and 10 on the millimeters. Now this one is pretty much exactly on the 5, and this can be read to 2 decimal places. So this would be 105.00 millimeters.